right, here we go. So we're going to use this PowerPoint. If there's questions anywhere, please let me know. We'll try to answer those again. We have a few more graphs to go through. Thank you. We've only done sine, cosine. Hopefully with the understanding of those, these others will come easier to you. We got to do tangent and then the inverse trig ones. So I think the first one we're doing today is tan. So starting off tan, this is what it looks like. Can you see around here? I'll re-explain it to you if you don't see it. You guys remember the unit circle? What were the coordinates? 1, 0, 0, 1, negative 1, 0, 0, comma, negative 1, right? So for this one, let's start at 0. Now, please remember that tan is the sine over cosine value, right? So I'm going to take 0 divided by 1 in this case. What's 0 divided by 1? 0. So I graph it here. Okay? Then if I go to the top over at 90, so I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. Let's go up to 90. So I'm taking 1 divided by 0, correct? Yeah. What's 1 divided by 0? Undefined. It's undefined. So guess what we get here at pi halves? We get an asymptote. If we go over to the next checkpoint, 0 divided by negative 1 is just 0. So we got a 0 here. Next stop is at 90. We get another undefined. So if you notice, that's actually the pattern that you get. And then you get another 0 here. If we do that in reverse, you'll see the same thing happens. You're going to get asymptote, 0, asymptote, 0. So it's kind of necessary for us to graph other points. But you can also just take a look at the graph here. It's just going to do this bit here. It's going to cross through. And it just repeats itself over and over and over. That makes this graph a little unique. It makes this graph unique because sine and cosine have a period of 2 pi. Take a look at this. What is the period of this bad boy? It's not pi halves.
Chinese class that came all the way from China, and they just want to see different types of learning.
Oh my gosh.
On the bad day. On the bad day.
Every time it's a bad day.
Every time that someone watches me, remember when the superintendent came in?
I told you.
All right. So, anyways, we're going. They got all excited. So if we take a look at this, this is repeating itself between every one of these asymptotes, correct? So let's identify these asymptotes. This is negative pi halves, and this is pi halves. So from negative pi halves to pi halves, what is the distance there? What is the range? Not the range, the domain there. It's pi. So for tangent, you're going to have pi as the period for it. Okay? So that's what's different from the other sine cosines. Here's some of the values that you're going to need. We already know how to find those. I'm just going to skip this. I never give that to you anyway. So we're going to slide over next part. Yes, so right here again. Period is pi. The domain, it's going to be in the odd multiples of pi halves. That's going to be gone. So here's what we're saying. Every so often, at those intervals, you're going to get a domain that is a part of the domain that's not there. It's your asymptotes. Holy smokes, it's huge. You guys got a huge group. Okay? Questions there? And domain, of course, goes from negative infinity. Sorry, range goes from negative infinity all the way up to positive infinity because these arrows are going forever and then they're shooting off forever. Questions on this?
Yeah, don't switch it.
We're not all in China. Really, Merlin? Yeah.
You're
really.
not?
Oh, no. Yeah.
How do we know you're getting it?
That's funny.
Oh my god.
Oh, is that for me?
Bye, Merlin.
You drew a pencil on me last year. No.
Don't make me pencil you again. Hey guys, say hello to yourselves on YouTube. You guys can check me out, Jay Munoz Math. Leave your likes and subscribe. Stop it. Stop. Seriously, say hello and then go back and watch yourselves. You'll listen to yourself. No? No takers?
No.
Okay. Now you can hear yourself say no. Alright, let's move on. Okay. So same thing. We already talked about all this. We got the asymptotes. X-intercepts are going to be... Go ahead.
Go back.
Go back to here. Bye. Have a good one, guys.
We need to clap.
That would have been funny.
Yeah.
I don't think so. They're just.
scared them, dog.
Wait, I haven't really
Say hello. He said,
Do they speak
I don't think you're right. I don't think they
I think
understood.
that's why they don't. They didn't.
That's why they
say
don't.
understood you.
Like one of them said hello.
Oh, they did? I didn't hear them.
They said hello.
You thought they said no?
I thought I heard them say no.
No, they said hello.
I don't think they understood you. You talked really fast.
And you're just talking.
Like it's over eyes, like
Okay. Welcome back to class. Remember, we're recording this. It's gonna be a long recording. All right, cool. So we're good with period, domain, and range.
Yeah.
Be careful with that domain. Even though it's all numbers, you're not going to get those multiples where those asymptotes are at, right? And that happens every pi halves.
Yes.
Okay. So moving on. At every multiple of pi halves. Intercepts, again, they're just going to be those zeros right there. This is an odd function. Odd function
Oh, why?
that has origin symmetry.
Why?
Same idea. If you plug in a negative, it's going to spit out the opposite of what you usually get. Okay. This one just happens to have origin symmetry, like you mentioned yesterday, but that doesn't make it necessarily true. Okay. Only if they're parent functions. I can change this.
So it locks
It doesn't have origin symmetry.
Yeah, it does.
Origin symmetry, yeah. This piece, if you flip it twice, it becomes that. Yeah, ignore all the others.
I thought you just flipped it once.
No, well, this is 1, 2, 3, 4. This is 5 periods of tangent, and we're only talking about 1 period. Okay.
So it's all, like, every time you have tangent, it's going to be a period of
Pi.
pi.
Unless
There's a stretch.
there's stretches or compressions and phase shifts and all that. So, yeah. But yes, this is the mother function.
So would it be an even function?
No, this one's odd.
Oh yeah.
They were taking pictures of it.
Of what?
Oh, you got there. Terry's taking pictures.
Oh, cool.
Yeah, I was like,
I want to go to China.
You want to go to Asia?
they're like, I want to go to
Anywhere other than
I want to go to my dream.
I always wanted to go to Egypt. I want to see the
Oh, yeah.
Sphinx and the pyramids, but
Oh, if you pull up Google Maps right now, I can find it.
Probably human.
I have it memorized.
More human than not.
why?
let's go to Italy.
Yeah.
All right, cool.
Italy. I would go to
What? Not done? Okay, moving on. Just more information. Again, this can also have your stretches and your phase shifts and all that good stuff. So there's your A, there's your B, there's your C. And yes, you can also even, why don't they have it on there? You can even shift it up if you wanted to. Okay? It's going to be kind of weird, but it is what it is. What's on here that we haven't talked about?
My coordinate is negative
It doesn't.
My coordinate is A. My coordinate is A.
Well, if you think about it,
Wait, can I go up and down?
yeah. So when you graph these, that's actually a good point. Thank you. I did miss that one. Thank you. Remember how we always depended on the vertex to graph stuff, move it around and stuff? This doesn't have a vertex, but it has a center there, and that's what you're going to follow around, move it up or down. And then when you decide if it's going to go, how far up it's going to go, you do want A here, and then over here you're going to want negative A, kind of like that amplitude still. Okay, because tangent will do that. When you do stretch compressions, it doesn't look like sine cosine where it kind of looks longer. It'll do more of like this, and it'll kind of do this bit. It's kind of weird. I don't know if you can see it, if I'm doing it right or not. Oh, I'll draw it. So it might get like steeper, or it might get even flatter. Kind of like the cube, remember? You guys remember the cube function when I showed you guys that?
I don't know how to word it. Like the middle part,
Gets flatter and flatter kind of thing?
it won't.
It can, it depends on if you have a K, right?
So if you have a K, the little, like the middle of the line.
This guy will shift up, and you'll create a new midline and all that good stuff. So nothing's changed, it just looks different. Okay? Alright, so why don't you guys try graphing this first? And you want to go from -5/4 over to 3/5. Real quick, how many periods are you graphing here? Alright, go for it. We'll talk about it right now. I'm going to try to get this thing to open up for me.
One second.
Oh, wait, that's like.
Does anyone have lead?
Nobody has lead, they have graphite.
You know what's the answer?
No, I'm not.
Make sure OneDrive, Pastor Greg, you can type this one easier.
Oh, ow.
That sucks.
OneDrive.
I'm pretty sure I'm
Really? That's
Okay.
Don't tell her. Don't say anything. I said
I think it was good. And then like whatever is
Okay. So just based off of the, you guys good? Are we tap? Did everybody tap already? No? Alright. So I've just drawn a sketch of what I would normally have if it was sine, cosine, or whatever. And I'm going to take a couple things that I know already. I already know that the original period for this thing is just pi, right? How fast is this guy moving? Twice as fast. So does that mean I'm going to have more in my domain or less in my domain? I'm going to have less in my domain, right? Now, was there a horizontal shift here? No. So where should I have? Definitely should have it at 0, correct? My first point.
Yeah.
Now, because it's not a full pi, it's just gonna be half pi, correct? On my period now. That means that here, at the quarter points, because that's half of a half, that's where my new asymptotes will be. So there's one asymptote. There's the other asymptote. Now the next question is where should I put my other 2 points, right? And Sienna, you can help with that? So when I go here, where am I going to go up? How many? 3. So it should be like right about there. That should have 1, 2, 3 down as well. So my tan will do something like this. Okay? And all I have to do is reproduce that same image as far as I need to the left, to the right, and as far as I need to the left. I forget my hands are flipped when I'm looking at you. Right? Not a big deal. I might have exaggerated my curve there because I'm not perfect, but if you really want to take a look at it, throw it into your graphing calculator.
Then that would repeat pi over 2, right?
Yeah, so it would repeat every pi half distance. So it would go another one here. Right? If I'm doing this right, yeah, I just made this separate a little bit more, so it would be repetitive. Just make sure that you're only going pi distance, okay? Because usually it would go from pi half to negative pi halves to negative pi halves, but now we're going to go half that distance from negative pi fourths over to pi fourths.
So then if it was 1 half x, then it would be like it's going all the way to pi and negative pi, right?
If it was, say,
So it says like 310,
310 1 half x, then that means you're going slow.
so then would it be
So you're going to do twice the speed. So if you're normally pi, then you would go all the way to 2 pi.
So then would it be pi?
So it would be much easier. You would be your graph would go from here to here, and the reason for that is that there's no horizontal shift. There's no phase shift.
So what period was pi? Oh, sorry.
What period is pi?
What was the period?
The original period is pi. My new period is pi half. You can still use what is it? Actually, it would be different, right? Because here it would be pi over b. It would be pi over b.
Oh, it's pi over b. It's not 2 pi.
No, not for this one. Because the period for this is pi. Sine and cosine have a period of 2 pi. So my period for this would be pi halves. Does that make sense? Anybody questions on here?
Yeah. So
Go ahead.
the A part, you showed it. Is that when it stops? Like it goes instead of the little sprinkly, it goes to the big sprinkly.
Yeah, there's one point. I'll show you which point it is. See this point right here?
Yeah.
Usually it would go to 1. So this would be like whatever interval, which would be pi quarters, correct?
Yeah.
And then I would, pi half, pi quarters. So I would go up to 1, normally. But because this thing is going faster, I'm going to have to go at 1/8. I would have to go up to 3. Think about A. You remember how I always do the unit circle, and it goes 1, 0, 0, 1, negative 1, 0. Okay? Think about A as making the circle bigger, 3 times bigger in this case. Does that help a little bit for some? That's what you're really doing. So now instead of being 1, 0, now it would be 3, 0, 0, 3. Okay? Because that's what A is doing. You're looking at a bigger circle. It's stretching it. Okay? Cool. ABC's two consecutive asymptotes. Here's a nice way of seeing that too. I'm more of a visual guy, so can I erase all this junk? It actually looks kind of cool. Oh.
I see it shaking.
Oh. Okay. So here's what you can do as well. We know that this bx minus c is going to be. You guys remember that from the phase shift stuff? So they're just plugging stuff in, and then you eventually figure out where you should be at. But again, that doesn't take into consideration. Okay. All right. So midways, that's just so much. You guys okay with what I did? That's why I don't like doing these presentations this way. They just kind of drive me a little
Oh my
crazy.
gosh, Mr. Munoz.
Yeah.
You know how you see the thing shaking?
Yes.
I don't think it's actually shaking. I think it's just the pixels like shifting.
No.
It is actually.
Well, it will shake. Right now, it's not shaking. It's the bulb that's been going out for almost half a year, so it's kind of shifting intensity. Does that make sense?
That's what I thought.
Sometimes you actually see it get brighter,
Yeah.
and
Like,
sometimes
I
it'll
see, like darken and then bright.
no, literally, like it'll actually get a little bit brighter. But now,
I see it like flashing.
yeah, but I don't think we have enough for everybody yet. And I think I'm doing fine right now. The lights don't have to be off. Like I have some teachers like next door. Even when you turn the lights out and close the windows, you can still barely see it. So it's like I don't have an emergency. Okay.
Yeah, Miss White, go back.
Oh my God! It's still more of the same.
Ow.
Ah,
Oh.
ah,
Love that.
ah. Okay. Guess what they did here?
Oh,
They
where's this at? Well,
No, this is cotangent.
They
what?
So technically, yeah, they did flip everything, didn't they? Okay. Now, I want to point this out, guys. Tangent. The tangent graph was and zeroed, right? See it?
Yeah.
Cotangent does not do that. It doesn't just flip it. So what I'm saying is, my original tangent went from negative pi to pi, so it crossed right through the origin, kind of thing. The cotangent does not. The cotangent, yeah, it zero. Oh, okay. Think about it this way. In tangent, there was zeros and there was asymptotes, correct? When you make a cotangent, those flip. All the zeros of tangent become the asymptotes for cotangent, while all the asymptotes become zeros. And it should make sense, right? Because it's zeros and ones, correct? So if a 0 was 0 over 1, and it's cotangent, that means you got to flip them, so that ends up putting the 0 on the bottom for that. And then it follows that graph, but they go the other direction as far as all the other points. Okay? So right here, let me do red here. This is y, and there's x. Okay?
Dang, that was a straight line until then.
I just kind of gave up at the end. I should have followed through. It would have been impressive. You know what? What were we saying? JK, smiley face. So, cotangent also has a period of pi.
Why is it different from whenever we already got cosine?
This is cotangent, not tangent. Remember, this is the reciprocal of tangent. Okay? So everything gets kind of funny. All your asymptotes before become zeros. All your zeros from before now become asymptotes. Okay?
Okay, so it's just shifted.
No, because tangent goes bottom to top, and this goes top to bottom. So it's kind of like you flip that as well.
Okay, so
Okay.
you shift it and flip it.
Correct.
Okay.
No shifts. There's no shifts.
What?
Their face.
Well, if you want to call it that.
It's
If it makes sense to you, let's just not say it to everybody. We okay with its characteristics?
Yeah, well,
Oh, you opened! It's about time. We're good with this slide? Lexus, you good? Okay. Whoa, go back. Okay, so here's one graph, one period of it. The period on this is also pi, except it starts at 0 and goes to pi versus negative pi halves to positive pi halves. Okay. It's nastier, but they'll do it. They'll do it. They shouldn't,
frisk.
but they can do it.
Oh my god, does that mean this frisk?
okay with the graphing part? That way I can spend more time on the cosecant and secant one?
Yes.
Because this isn't too bad, right? Like, you know what's supposed to happen. The other ones are a little trippier.
But is this an even or odd number?
This is odd. Thank you for asking. This one's going to be odd. Good one. Look at you, girl. This can have the right question.
I don't want to hop this last
He said it.
That's good stuff.
I had deja vu yesterday.
Okay. Now, like I said, these make sense, but when we get to cosecant and secant, they just go, what? I want to show you. Let me end this real quick. I will end you. I want to show you with my handy dandy calculator. Where are you? Do you guys see my Inspire? Is it up here?
I don't see it.
Please tell me I installed it.
Who?
Type it in.
Oh, can I?
Yeah.
Oh, duh. Inspire. I don't. Sad
Wait,
face.
Inspire
Inspire. All right, I'm gonna try the new one. I'm gonna try the smart view. I see. Hopefully, it'll be a little bit nicer.
I wish like the recordings could get some of your faces sometimes. You just make some real funny faces towards people with their confidence.
I used to have a camera. I took it down. I don't know if you guys noticed it.
That's what
For
I thought.
two reasons. One, it would turn off eventually after by itself because it was stay plugged in. The quality is not that good. And I had people that kept walking in front of the camera, and I can't have that happen. Okay. All right.
My
So
dad has that one.
here we go. Let me clear these up. Now, please remember that cosecant is simply the reciprocal of sine, correct? So I'm gonna have to graph it that way. So just an FYI for you guys, if you're gonna want to graph cosecant or secant, you have to do it as a quotient. So 1 divided by, I'm gonna do cosecant first, and here's how I would graph it. Okay. I'm okay with that? Now, I'm hoping you guys will be like, what? And if you're not, then
What?
Wait,
Get it.
wait. Is that what the heck?
I know it. I know.
So
that's not legal. That's illegal.
they're just like, you just
Oh, yeah. Oh, I remember.
This is cosine right here. I'm sorry. This is cosecant. This is the function for cosecant. And that's the reciprocal of sine. Okay?
I think they were just like, yeah, you guys aren't gonna touch. Sorry, don't do this. Rude here. It makes sense because like, I guess it would make sense because like they're still going in the same direction. They just don't touch. They're still going like it still has like if you look at it, it still has a kind of form of the S, like an S. Wait, I think. Yeah,
Yeah, it like just cuts in half.
Okay. I want to
it makes sense.
try to make a little bit more sense out of this for you guys. So this is cosecant. So I'm going to change my window, and I'm going to change my Inderburg, my X scale, and I'm going to change it to be in terms of pi. Didn't know you could do that, could you?
No, sir.
Oh, cool. I was just messing around. Anybody know why I want to do that? Because
I don't know. That's how we always graph it.
yeah, we graph them in intervals of pi, don't we? So now take a look at these numbers.
Numbers.
Well, yeah, they are. What is this here? That's pi. This is 2 pi. This would be 3 pi.
So each period
This
just
is negative
one
pi, negative 2 pi, negative 3 pi. What's happening to every interval of pi? You don't see it because the calculator knows.
Is there
Asymptote.
Yeah. Those are asymptotes right here, guys. Every one of these is an asymptote. Turn to your elbow partner. You're going to figure out why. Why do I have asymptotes there at every interval of pi? We're going to let the dojo pick some people too.
Oh, what?
To quote my dear friend Maya, because sine doesn't have asymptotes, cosecant does. And cosecant does because cosine doesn't. Or no, sine doesn't, sorry. Oh, that's funny. That's good stuff. Let's get into the dojo. I don't want this to lock me in.
This is cosecant.
Okay.
Oh!
What's that?
What are you eating?
You can tell, just tell us if you
Why
like
do you sound so
Sour Skittles.
or not.
Are you kidding me? Those are amazing.
I don't have a lot of it, bro.
See, like right there. Let me put it.
Let's give you a box of warheads.
Ooh, those are fly.
I wasn't expecting that. If I don't have long sour,
Oh, you did it right here?
yeah, it blocks my jaw. And it hurts.
So sign.
Oh, breaking over here.
Glass clippings?
Just the triangles?
That was fun.
Zero, that's half.
How ironic.
No, okay. Is there something on my face?
Trying to figure out why.
Wait.
Okay. So,
How are we on time?
No.
Are you serious?
okay, look.
Yeah, 20 minutes.
We'll probably do this and then we'll stop.
Oh, yeah! What the hell?
Hey guys, don't talk too much. You might not get cold. Sarcasm.
She's really asleep.
I did it once.
Zero. Oh, you got it.
But I don't know how you.
The range is gonna be different than that.
No? No, you guys should
Yeah, but what the range is different?
Good job.
So like this, why the why the asymptotes?
What's up? What's up? What's up? What's up?
Wait.
We'll do it.
Remember, it still has a period of pi though.
So it would be the same thing.
Like right here, like this.
Well, first of all, it's the.
Oh, zero.
It did pick you, but I'm skipping you because I know you got the answer.
Oh, you?
You said I wish it would, and I clicked it and said Ernesto.
Oh, me?
Right.
No, don't skip me. I want to say it.
Okay, say it for everybody.
Okay.
Hold on.
So.
Hold on. Okay, now you
Why is my thing orange?
You should get that checked.
On the.
Okay.
Wait, what is it?
That's disgusting. But, the year.
Ew. That's a good circle.
Thank you.
Why is there
Oh, Trevor, can you see that? Can you hear him?
Okay. So.
You can erase the stuff above too. That's erasable.
I know.
We're
But
so
I don't know. What if
integrated.
someone needs it, Miss Munoz?
No, that was us. We needed it.
Okay.
Remember? Okay, cool. Nice circle, by the way.
So whenever this is cosecant.
Yeah.
This is cosecant up here, correct?
Okay, so is the inverse of sine. So whenever sine's at 0, it would be
It would be 1, 0.
1, 0, and then when the radius is 1, sine will equal y. So y is 0, so that'd be sine, but if you put 1 over 0 to be the cosecant, then it will be undefined. So that point happens right here and at pi, which is negative 1, 0.
So it happens when you're at 0 degrees, see the asymptote? And then after you traveled pi, you get asymptote. And then you're going to travel another pi, you get asymptote, asymptote, asymptote. So yes, all those are asymptotes. For your visual people, graphing this thing is going to be kind of weird. We're not going to graph cosecant when we graph these things. We are going to graph sine, and we're going to leverage sine to graph cosecant. And we're going to show you why we do this. Because for starters, that thing is ridiculous. But I'm going to leverage oh, that's pretty. Clear ink. I'm going to go ahead and graph on the next line my sine function by itself. And then you'll see, hopefully, with your own eyes, why we're going to graph sine. Because we know how to graph sine, right?
Yeah.
We're good. I'll do that all day. To graph the inverse function of it. Sine is inside of
Oh
there.
yeah, I did that just now.
Do
I
they
did that.
actually touch, or is it?
Yes,
Yeah, they
they do.
actually touch.
Oh, because it connects. Sorry.
Period.
Yeah, see.
So, for those visual people, you see how right here there's a 0,
Yeah.
aka a 0 for sine. So if I took sine, technically 0, and I flip it, which is exactly what you said, yeah, that becomes an asymptote for the cosecant. So what we will do when we're trying to graph one of these cosecant functions is we're actually going to graph the sine, and then here's what you'll know. All the zeros of sine will become asymptotes, and all of the peaks, and I forget the other word, all the peaks on sine will become the, oh, is it a cusp? Is the cusp at the top?
Oh, I think it cuts.
No. But anyways,
Excuse me for this interruption. Fourth hour teachers, if any of the students that were on the roster to take the
none of you guys are seniors, right?
test at
You didn't get it,
12:15 in the library, those kids need to be sent out to the library at this time. Please refer to the email that you were sent with the attachment. Any of the seniors with that voice slip, they go to the library at 12:15. Please report now. Thank you.
Okay, so everyone understand what the plan is here?
Yeah.
When you want to graph cosecant or even secant or cosecant, you'll graph its original function. All the zeros will become the asymptotes, and then all of the apex will become, all the maximums will become a minimum to the other part of the curve. And of course, you'll just move towards the asymptotes, towards infinity in both directions. And you can just examine that and you see what's going on, right? So, good job, Gary, noticing that beforehand. That's what it is. It's just that simple. Okay? So if I want to graph, how are we on time?
You have 12, 13.
Okay, so let me show you. Oh, good stuff to know. Write it down. Cosecant period is 2 pi. That makes sense, doesn't it?
Yeah.
Because it's the reciprocal of
Sine.
sine, therefore it should still have the same period. Domain is all numbers except for those intervals of pi where you get that asymptote. And the range is going to be all real numbers except where the sine function kind of is, which would technically be a, right? It would technically, how do I say that?
Well, it would.
If sine had an amplitude or a range of some sort, that would be the gap for the cosecant. Does that make sense? Because here's the way that I visualize it is that they've taken this function here, they've cut it right at the midline, and they flipped it upside down. See that? That got flipped upside down, flipped upside down, flipped upside down. And that's what became your new function. Because it makes sense, right? Reciprocals are flips.
Yes.
Connect, connect, connect. 4 years ago. Why did that pop in my mind? Who said something good? Can I change side?
Is today Thursday?
No, today is Thursday.
Huh?
That happened so fast.
What happened fast?
No, it's because we're going by so slow.
What?
What?
Is today Thursday?
No, today is Thursday.
Today is Thursday. No, today. Not today.
That's what I thought I said. Okay. This one is an odd function. Kind of makes sense since sine was an odd function, then cosecant should be an odd function. Here's your secant. It's 2 pi. It will have the multiples of pi halves. It's still at every pi interval where it's an asymptote, but we call them the intervals of pi halves. It is an even function again. And then we're going to practice some graphing, which I think you guys are good, right?
Yeah.
You'll actually graph sine versus cosecant. And then you'll kind of do what I showed you to do a second ago.
Wait.
There's the whole,
Go
go back to here,
Is that it?
to here. It's an even function. Bada boom, bada bing. Chimney, chim, chimney, chim, chim, chim.
So dead right
Queenie, what are you doing?
We only have like.
Guys, that's it. All the others are just examples.
Yes, done.
That's a good thing. This was supposed to go on for 2 days.
That's it. Like, yes, done.